Welcome again. Now we want to move to 2.4, dimension analysis. Now, dimension is a very important aspect of physics. In fact, all the formula that we know, they are actually correct based of dimension. They are correct because they are dimensionally consistent. If they are not dimensionally consistent, they are not correct. Dimension is one of the ways of checking the correctness of a formula. When a formula is not dimensionally consistent, then the formula is not correct. We'll see that as we go. Now, the dimension of any physical quantity expresses its dependence on the base quantities as a product of symbol or powers of symbol representing the base quantities. Now, when we are talking of dimension, you remember we talked about fundamental quantities. Dimension are based on this base quantity or fundamental quantities. So any formula that cannot be expressed that is not dimensionally consistent is not correct. In general, the 7 fundamental quantities and their dimensions are, we are going to look at the 7 fundamental quantities and their dimension, and we'll see how important this idea of dimension is. We have looked at length. Length is one of the fundamental quantities. This time around, we are not talking of the unit, but the dimension of length is capital letter L. That's the dimension of length. Mass, the dimension of mass is capital letter M. The dimension of time is capital letter T. The dimension of electric current or current is capital letter I. The dimension of temperature is theta. The dimension of amount of substance is N. And the dimension of luminous intensity is J. Physicists often use square brackets around the symbol for a physical quantity to represent the dimension of that quantity. Let's say we want to find the dimension of radius. We have to put the radius in a square bracket, just like this. You can see the radius in a square bracket. And what's the dimension of radius? It's L. Since when we are talking of radius, the unit of radius is a meter. And so it means radius is length. And so since radius is length and the dimension of length is L, it means the dimension of radius is L. Any quantity with a dimension that cannot be written so that all 7 powers are 0 is called dimensionless quantities. We have some quantities that are also dimensionless. That is, they cannot be the power of the dimension of these quantities are 0. So that makes them to dimensional in the sense that if you know anything raised to the power 0 is 1. For example, 2 raised to the power 0 is 1. So if you have a dimension, a quantity whose dimension is 0 raised to the power 0 is 1. So any quantity that is dimensionless is actually 1 or has its power to be 0. Now, physicists often call dimensionless quantities pure numbers. They are pure numbers. So pure numbers are dimensionless quantities. So it means we cannot find the dimension of pure numbers. Now let's look at some brief example. What is the dimension of the area and B, the circumference of a circle? Number 1, the area of a circle is pi r square. Pi is dimensionless. Why? Because pi is a number, is a constant, and that constant is 3.142. So it makes it to be dimensionless. So since it is dimensionless, we neglect it. We cannot find the dimension of it. So pi r square is reduced to r square, and r is radius, and radius is length. So it means r square equals to L square. So that the dimension of area is what? Is L square. And the second one, the circumference of a circle is 2 pi r. 2 is a dimensionless number, the quantity. It is a pure number. So you cannot find the dimension of 2. Likewise, pi is also dimensionless. So 2 pi r is reduced to r, which is equal to L. So that the dimension of circumference of a circle C, I've said that it will be written in square bracket, equals to L. Number 2, consider the quantities S, V, A, and T with dimensions S equals to L, V equals to LT minus 1, LT raised power minus 1, and A is LT raised power minus 2, and T equals to capital letter T. Determine whether each of the following equations is dimensionally consistent. A, S equals to Vt plus 0.58t square. B, S equals to Vt square plus 0.58t, and C, V equals to sine AT square over S. Now the first one, for an equation to be dimensionally consistent, it means the equation must be correct. And for it to be correct, it means the left-hand side of the equation must be equal to the right-hand side. Now if you look at the first question A, which is S equals to Vt plus 0.58t square, you discover that the left side is S, and S is what? Is distance. And so what's the dimension of distance? The dimension of distance S is L, and the right hand side is Vt plus 0.58t square, right? So what's the dimension of Vt? Already we have been given V as Lt minus 1, Lt raised power minus 1. Lt raised power minus 1 is the same thing as L over T times T. The dimension of T here has been given as T, which is T here. So cancel out. You are left with Vt becomes L. Likewise, the second part, 0.58t square. 0.5 is a pure number, so it is dimensionless. So we are left with 80 square. And A is Lt raised power minus 2, which is the same thing as L over T square. T square again times, T as capital letter T. So that will be capital letter T square. This one also cancels out. We are left with L. So that the right hand side becomes Vt plus 0.58t square equals to what? L plus L. That is 2L. Again, this is dimensionless, so it is L. Now, the left hand side is L, the right hand side is L. L over L, so it is dimensionally consistent for the first one. Now, the second one, S equals to Vt square plus 0.58t square. S again is L, since S is distance, and distance is length. Now Vt square, V, the dimension of V as given in the question, is Lt raised power minus 1. So that's L over T. And T, the dimension of small letter t is capital letter T, so that's times T square. So T cancel T, you are left with Lt here. 0.58T. 0.5 is dimensionless, it is a number. So you are left with 80. And 80, A there is L over T square, and T there is T. So you are left with what? L over T. So that the right hand side becomes Vt square plus 0.5 Vt square becomes L over T, Lt plus L over T. If we find the LCM here, you have this. And so, on the right hand side is the left hand side is L, and the right hand side is this. They are not dimensionally consistent, since the left hand side is not equal to the right hand side. And number 3, V equals to sine AT square over S. Sine is dimensionless, so you are left with V equals to AT square over S, and V is L over T. That's the dimension of V, that's the left hand side. AT square, A is L over T square. T square is capital letter T square divided by S, which is L. So that this becomes, the right hand side becomes L when this cancels out over L, which is 1. So the left hand side is L over T, the right hand side is 1, L, and they are not the same. So not dimensionally consistent. And number 3, what is the dimension of dv dt? And B, the dimension of integral of v dt. Now, dv dt, when we want to find the dimension of the derivative of any physical quantity, we neglect the derivative. We only look at the physical quantity. What you have there is v and t. So the dimension will be the ratio. So it will be the ratio of the dimension of v and t. Now, v is L over t and t is capital letter T. So that v over t now will be L over t over t. That's L over t square, which is equal to L t raised to power minus 2. And actually, dv dt is acceleration. The derivative of velocity is acceleration. So, and the dimension of acceleration is also this. Now, integral of v dt, what's the dimension? You neglect the integral sign and the derivative sign. So you are left with the product of v and t. So it means we are going to find the dimension of the product of v and t. The dimension of v is L over t and the dimension of small t is t. This cancels out, that's L. So the dimension of the integral of v dt is L. So which is actually true because integral of v dt is actually displacement or distance. So and the dimension of distance is what? Is L. Lastly, what is the dimension of acceleration and surface tension? Now, acceleration, the formula for acceleration is velocity over time equals to what? And velocity is displacement over time. This is the formula for velocity. Now, so we can write it as displacement over time, then over time, and which can be written as displacement over time times 1 over time, which is displacement over time square. Displacement is distance and distance is length. So that is d equals to L and t square will be t square. So acceleration is Lt minus 2. You will agree with me that it is the same thing as what we did the other time here. Lt raised to power minus 2. That's also acceleration. And the second one, surface tension. The formula of surface tension is force over length, and force is mass times acceleration. Mass is capital letter M, that's the dimension of mass, times acceleration is L t raised to power L over t raised to power 2. So that this becomes ml over t raised to power 2. And length is L. So that surface tension, S in square bracket, will be ml over t square divided by length, which is L. So that will be ml over t square times 1 over L, which is m t raised to power minus 2. So the dimension of acceleration is m t raised to power minus 2. Thanks.